Welcome to this comprehensive session on orchestration and deployment strategies in Kubernetes. Throughout this session, we'll explore various deployment strategies that can help you manage your applications more effectively in a Kubernetes environment. Whether you're new to Kubernetes or looking to optimize your existing deployment processes, this module will provide you with valuable insights and practical knowledge that you can apply in your own DevOps journey. Let's begin our exploration of these essential concepts together. Let's dive into the world of Kubernetes deployment strategies. In modern DevOps practices, how we deploy applications is just as important as the applications themselves. Kubernetes offers us multiple sophisticated strategies for deploying applications, each designed to address specific needs and scenarios. Today, we'll explore four main strategies: rolling update, blue/green deployment, canary deployment, and the recreate strategy. Each of these approaches offers different trade-offs between availability and update control, and understanding these trade-offs is crucial for making informed decisions in your deployment process. For instance, if you're working in a financial services environment, you might prioritize zero downtime deployments, making blue/green or rolling updates more appropriate. On the other hand, if you're in a development environment where brief interruptions are acceptable, the recreate strategy might be sufficient. The key is understanding these strategies well enough to choose the right one for your specific use case. As we progress through this module, we'll examine each strategy in detail, discussing their advantages, potential challenges, and real-world applications. The rolling update strategy is Kubernetes' default deployment method, and for good reason. It's designed to minimize disruption while ensuring your application remains available throughout the update process. Let me explain how it works in detail. Imagine you have a deployment with 5 pods running version 1.0 of your application. When you initiate a rolling update to version 2.0, Kubernetes doesn't update all pods simultaneously. Instead, it gradually replaces old pods with new ones, maintaining a specified number of replicas throughout the process. This means it might take down one pod running version 1.0, replace it with version 2.0, wait for the new pod to become ready, and then move on to the next pod. This process continues until all pods are running the new version. One of the key advantages of this approach is that it maintains application availability throughout the update process. However, there are some important considerations to keep in mind. First, during the update, you'll have both old and new versions of your application running simultaneously. This means your application needs to be designed to handle this situation, particularly regarding database schemas and API versions. You also need to properly configure your readiness and liveness probes to ensure Kubernetes can accurately determine when new pods are ready to receive traffic. Rolling updates can be particularly effective for stateless applications where backward compatibility has been properly maintained. However, poorly configured health checks led to failed deployments, so proper configuration is crucial. Here's a practical tip. Start with small batches in your rolling update configuration. You can control this using the max surge and max unavailable parameters in your deployment configuration. This gives you better control over the update process and makes it easier to catch potential issues early. The blue/green deployment strategy is one of the most powerful approaches in our DevOps toolkit, particularly when zero downtime updates are critical. Let me walk you through how this works and share some real-world insights. In a blue/green deployment, you maintain two identical environments: blue, which represents your current production environment, and green, which is where you deploy your new version. The beauty of this approach is that it completely eliminates downtime during updates. Here's the process in detail. Let's say your current production environment, blue, is running version 1.0 of your application. When you want to deploy version 2.0, you set up a complete new environment, green, with all the necessary infrastructure, pods, services, and other resources. You then deploy version 2.0 to this green environment. The key point here is that your blue environment continues serving production traffic while you thoroughly test the green environment. Once you're confident that everything in the green environment is working correctly, you perform the switch. This is typically done by updating a service or ingress configuration to point to the green environment. If any issues arise, you can quickly switch back to the blue environment. This is what we call a quick rollback capability. However, there are some challenges to consider. Blue/green deployments require double the resources since you're maintaining two complete environments. This can have significant cost implications. Additionally, you need to carefully handle stateful applications and database migrations. This can be a good strategy for critical customer-facing applications where even a few seconds of downtime could have serious consequences. A practical tip I've learned: always maintain good monitoring and logging for both environments, and establish clear criteria for what constitutes a successful deployment before making the switch. Also, consider implementing automated smoke tests that run against the green environment before directing production traffic to it. The canary deployment strategy, also known as A/B testing in some contexts, is a sophisticated approach that allows us to minimize deployment risks while gathering valuable user feedback. This strategy gets its name from the historical practice of coal miners using canary birds to detect dangerous gases. If the canary stopped singing, the miners knew there was trouble. Similarly, in DevOps, we use canary deployments to detect potential issues before they affect our entire user base. Here's how it works in practice. Instead of updating all instances of your application at once, you introduce the new version to a small subset of your users, typically 5 to 10% of your traffic. This allows you to monitor how the new version performs in a real production environment while limiting any potential negative impact. The beauty of this approach is that it provides actual user data and performance metrics before committing to a full rollout. The A/B testing variant of this strategy is particularly useful when you want to compare different versions of a feature. For instance, you might want to test different UI layouts or different algorithms to see which performs better. The key difference from a simple canary deployment is that A/B testing is often more focused on business metrics rather than just technical performance. However, there are important considerations to keep in mind. You need robust monitoring and analytics in place to make data-driven decisions. You also need to ensure your application can handle running multiple versions simultaneously, which might affect your database schema design and API versioning strategy. Start with a very small percentage of traffic, 1 to 2%, and gradually increase it as you gain confidence. Make sure you have clear criteria for what constitutes success or failure, and have automated rollback procedures in place. Also, consider using feature flags in conjunction with canary deployments for more fine-grained control. The recreate strategy is the simplest of all deployment approaches, but don't let its simplicity fool you. It has its place in the DevOps toolkit. This strategy follows a straightforward process. It terminates all instances of the existing application before introducing the new version. While this might sound drastic, there are scenarios where this approach is not just acceptable but preferred. Let me explain how it works and when you might want to use it. In a recreate deployment, when you want to update your application from version 1.0 to version 2.0, Kubernetes first terminates all pods running, version 1.0. Once all old pods are terminated, it creates new pods with version 2.0. This process does result in downtime, as there's a period where no instances of your application are running. You might be wondering, why would anyone choose this strategy? Well, there are several valid use cases. First, it's useful in development and testing environments where downtime isn't critical. Second, it's appropriate when you have major version upgrades that require a clean slate. For example, when you need to perform database schema changes that aren't backward compatible. This strategy can be used effectively in scenarios where applications required exclusive access to shared resources. For instance, in a project involving batch processing systems, We used the recreate strategy to ensure there was no overlap between different versions trying to access the same resources simultaneously. However, there are important considerations. The obvious drawback is downtime. Your application will be unavailable during the update process. You need to ensure your system can handle this interruption and that your users are properly notified if necessary. Also, consider the impact on any dependent services. Some practical tips. If you're using this strategy, make sure to implement proper health checks in your application. This helps Kubernetes determine when the new version is ready to accept traffic. Also, consider implementing a proper backup strategy and have a rollback plan ready in case something goes wrong during the deployment. Let's talk about one of the most critical aspects of deployment strategies, the rollback process. In the world of DevOps, things don't always go as planned, and having a reliable rollback strategy is just as important as having a good deployment strategy. The ability to quickly and safely revert to a known good state can be the difference between a minor hiccup and a major incident. Kubernetes provides robust rollback capabilities through its revision history feature. When you perform updates to a deployment, Kubernetes maintains a history of the revisions, allowing you to roll back to any previous state. This is incredibly powerful because it means you're not just limited to rolling back to the immediately previous version. You can potentially roll back to any version in your history, depending on how many revisions you've configured Kubernetes to maintain. One crucial point to understand is that rollbacks aren't just about the application code. When planning your deployment strategy, you need to consider database schemas, API versions, and any other dependencies that might affect your ability to roll back cleanly. This is particularly important in microservice architectures, where different services might depend on specific versions of other services. Understanding how to view and manage your deployment revision history is crucial for effective rollback operations in Kubernetes. The kubectl rollout history command is your window into the past states of your deployments, and knowing how to use it effectively can save you valuable time during critical situations. When you run kubectl rollout history deployment number net shows you a list of all the revisions it has stored for that deployment. Each revision represents a different version of your deployment configuration, including the container image, environment variables, and other specifications. By default, Kubernetes keeps the last 10 revisions in history, but you can modify this using the revision history limit parameter in your deployment specification. Let me share a practical tip. While it might be tempting to set a high number of revisions, consider the resource implications. Each revision consumes some etcd storage, so you need to balance the ability to roll back to older versions against resource usage. A key point to remember is that the revision history doesn't just show you the version numbers, it also includes change cause annotations if you set them. I strongly recommend using the -record flag when making deployment changes, or better yet, setting the kubernetes.io/change cause annotation explicitly. This provides valuable context about what changed in each revision, which can be crucial when you're trying to determine which version to roll back to during an incident. Rolling back to a specific revision in Kubernetes is a powerful capability that needs to be understood thoroughly. The command kubectl rollout undo deployment. Deployment name -ministo revision equals revision number is your tool for time travel in Kubernetes, allowing you to return to any previous state of your deployment. Let me explain the process in detail. When you execute this command, Kubernetes doesn't just blindly revert to the old configuration. It creates a new revision that matches the configuration of the target revision. This is an important distinction because it means you're not losing history, you're adding to it. This new revision becomes the current version, and you can still roll forward or back from this point. One critical aspect that's often overlooked is the need to understand what exactly changed between revisions. Before performing a rollback, I always recommend using kubectl rollout history deployment name -minus revision equals revision number to inspect the specific details of the target revision. This helps prevent surprises and ensures you're rolling back to exactly what you expect. Always test your rollback procedures during non-critical times. There can be situations where teams discover their rollback processes don't work as expected only when they needed them most. Regular testing of rollback procedures should be part of your DevOps practice. Also, consider the implications of rolling back when you have dependent services or database changes. You might need to coordinate rollbacks across multiple services to maintain system consistency. Having a clear rollback strategy documented and practiced is essential for handling such scenarios effectively. Verifying the success of a rollback operation is just as crucial as the rollback itself. In DevOps, we never assume an operation was successful without verification. Let's discuss the essential commands and processes for ensuring your rollback was completed correctly and your application is functioning as expected. The kubectl rollout status command is your first line of verification. When you run kubectl rollout status deployment name, Kubernetes provides real-time feedback about the progress of your rollback operation. However, don't stop there. The kubectl describe deployment name gives you detailed information about the current state of your deployment, including the image versions, replicas, and any conditions affecting the deployment. But verification goes beyond just checking the deployment status. Here's a comprehensive verification checklist. 1. Check the pod status and logs for any errors or warnings. 2. Verify that the correct number of replicas are running. 3. Ensure all health checks are passing. 4. Monitor key metrics like error rates and response times. 5. Verify the functionality of critical business operations. Now we're moving into the hands-on portion of our module. The assignments that follow are carefully designed to give you practical experience with Kubernetes deployment strategies. These exercises will help you build real-world skills that are valuable in any DevOps role. As we proceed through each assignment, you'll gain hands-on experience with Minikube, create and manage pods, work with deployments, and understand autoscaling. Remember, the goal isn't just to complete these tasks, but to understand why each step is important and how it fits into the bigger picture of container orchestration. Let's begin with our first assignment. Let's dive into Assignment 1, which focuses on getting your local Kubernetes environment set up with Minikube. This is a crucial first step in your Kubernetes journey. Minikube is an excellent tool for learning and testing Kubernetes features because it creates a single node, Kubernetes cluster on your local machine. When installing Minikube, you'll need to choose the right configuration based on your system resources. The command minikube start -miniscapus equals 2 -minismemory equals 4096 is a good starting point for most systems, but you can adjust these values based on your available resources. One common mistake is not allocating enough resources, which can lead to performance issues later. The minikube status command is more than just a simple check. It provides valuable information about your cluster's health. When you run Minikube dashboard, you'll get access to a powerful web interface that visualizes your cluster's state. I encourage you to spend time exploring this dashboard as it can help you understand Kubernetes concepts visually. Create a simple shell script to start Minikube with your preferred configuration options. This helps maintain consistency in your development environment. Also, make sure to regularly check Minikube Update to ensure you're running the latest version with all the security patches and new features. Remember, this assignment is building the foundation for everything else we'll do in this course. Take the time to understand each command and what it does. Try experimenting with different configuration options to see how they affect your cluster's behavior. In Assignment 2, we're taking our first step into creating Kubernetes resources by setting up a simple pod. This might seem like a basic task, but it's fundamental to understanding how Kubernetes manages containers. The YAML file we're creating might look simple, but there's a lot happening here. Let's break it down. API version v1 indicates we're using the core Kubernetes API. The kind Pod specifies we're creating a pod resource, the smallest deployable unit in Kubernetes. Under metadata, we're giving our pod a name, which is crucial for identifying and managing it. In the spec section, we define the containers that will run in this pod. We're using Nginx latest as our image, which is fine for testing, but in a production environment, you should always specify exact version numbers to ensure reproducibility. Here are some important considerations when creating pods. Always consider using deployments instead of bare pods in production. 2. Be thoughtful about your container naming. 3. Consider adding labels for better organization. 4. Think about resource requests and limits. While this example is simple, it's crucial to understand it thoroughly. Many debugging sessions have led back to basic pod configuration issues. A practical tip: try modifying this basic pod definition by adding things like environment variables, volume mounts, or resource limits. This will help you understand how pods can be customized to meet different requirements. Assignment 3 focuses on verifying your pod deployment and understanding how to inspect Kubernetes resources. The commands kubectl get pods and kubectl describe pod are essential tools in every DevOps engineer's toolkit. When you run kubectl get pods, you're getting a high-level overview of your pod status, but there's much more you can do with this command. Try adding flags like -o wide for additional information, or -o YAML to see the complete pod specification. The -watch flag is particularly useful during deployments as it provides real-time updates. The kubectl describe pod command is your go-to tool for troubleshooting. It provides detailed information about a pod's current state, including pod events history, container statuses, network information, volume details, node assignment. The events section in kubectl describe output is particularly valuable for troubleshooting. It often contains the root cause of pod startup failures or other issues. Let's discuss the practical application of these commands. When you're managing a production system, you'll often need to quickly determine: is the pod running as expected? Are there any crash loops or restart issues? Is the pod scheduled on the correct node? Are the resource requests and limits appropriate? These commands help you answer these questions quickly and effectively. In Assignment 4, we're diving into one of the most powerful features of Kubernetes, deployments with autoscaling. This assignment introduces you to two crucial YAML configurations that work together to create a scalable application. Let's analyze the deployment configuration first. We're creating a deployment with 3 replicas, which is a good starting point for ensuring high availability. The selector and labels are crucial here. They're how the deployment knows which pods it manages. This is a fundamental concept in Kubernetes' declarative model. The horizontal pod autoscaler, HPA, configuration is particularly interesting. We're setting up automatic scaling based on CPU utilization with a target of 50%. This is a conservative and generally safe target. The min replicas, 1 and max replicas, 10 give us a good range for scaling while maintaining control over resource usage. Here are some crucial considerations. 1. The choice of metrics for autoscaling, CPU, isn't always the best indicator. 2. The impact of scaling on application performance. 3. The importance of proper resource requests and limits. 4. The need for proper monitoring and alerting. A practical tip: start with conservative autoscaling settings and gradually adjust them based on observed behavior and metrics. Keep a close eye on your application's performance during scaling events. Assignment 5 focuses on verifying and testing your autoscaling configuration. This is a critical skill in DevOps. It's not enough to just set up autoscaling. You need to verify it works as expected. The kubectl get pa command is your window into the autoscaler's behavior. When you run this command, pay attention to several key metrics: current/target replica counts, current resource utilization, Last scale time. Whether the HPA is able to successfully gather metrics. The Watch kubectl get pods command is particularly useful during scaling events. It provides real-time visibility into pod creation and termination. I recommend running this in a separate terminal window while you're generating load. Speaking of load generation, while it's marked as optional, I strongly encourage you to practice this part. Understanding how your application behaves under load is crucial for production readiness. Tools like Apache Bench, AB, or Hay are excellent for this purpose. However, remember that synthetic load testing might not perfectly mirror your production patterns. Here are some important aspects to watch for. 1. How quickly does the system respond to increased load? 2. Is the scaling smooth or does it oscillate? 3. How does your application perform during scaling events? 4. Are there any resource constraints affecting scaling? Assignment 6 focuses on proper cleanup of Kubernetes resources. While this might seem like a simple task, proper resource cleanup is crucial in both development and production environments. The kubectl delete commands we're using will remove the resources we created during our exercises. However, there are some important considerations to keep in mind. 1. Order of deletion. While Kubernetes handles dependent resources, it's generally good practice to delete resources in the reverse order of their creation. This helps avoid potential issues with resources that depend on each other. 2. Verification. Always verify that resources are actually deleted. Sometimes, resources might get stuck in a terminating state, which could indicate underlying issues. 3. Resource management. In a production environment, you'd want to use more sophisticated cleanup strategies, possibly involving namespaces or label selectors. Here are some best practices. Always use specific resource names rather than deleting everything in a namespace. Consider using -- grace period and -- force flags when necessary, but be cautious. Keep track of all resources you create, possibly using labels or naming conventions. Regular cleanup of unused resources helps maintain cluster health. A practical tip: create a cleanup script that includes all resources you typically create during development. This ensures consistent and complete cleanup after your testing sessions. We've reached the questions section of our module. This is an excellent opportunity to consolidate your understanding of Kubernetes deployment strategies and orchestration concepts. While specific questions aren't listed in the slides, I encourage you to think about several key areas. 1. Understanding deployment strategies. What are the trade-offs between different deployment strategies? When would you choose one strategy over another? How do these strategies work in real-world scenarios? Practical implementation. How would you implement each strategy in your environment? What challenges might you face during implementation? How would you monitor the success of different deployment strategies? 3. Troubleshooting and management. What common issues might arise with each strategy? How would you handle failures in different deployment scenarios? What metrics should you monitor for each strategy? The best questions often come from relating these concepts to real-world scenarios. Don't hesitate to ask about specific use cases or challenges you're facing in your own work. Remember, there are no silly questions in DevOps. Every question helps build a deeper understanding of these complex systems.